Question number 41. Two children of mass M1 and M2 are standing in equilibrium as shown in the figure on a uniform rod which is balanced at its center of gravity O. Then they are start moving simultaneously on the rods at constant speed V1 and V2 respectively while maintaining the horizontal equilibrium of the rod. Consider the following statements made about the motion of two children for the equilibrium to be maintained at any time t. Part A. They should always move in opposite directions. Yes, it is correct. We know that they have to move such that the change of momentum around point O, this point, should be equal. Then if this child is moving to this direction, this child should move to this direction, because of when moving to this direction the momentum is decreasing. Therefore there should be a decreasement of momentum for this child. Then A is correct. B. They should move keeping their total linear momentum always equal to 0. They should move keeping their total linear momentum always equal to 0. We can consider that decreasement of torque for this child M1 G into, I will consider the distance at x, should be equal to decreasement of momentum of this child M2 G into y. We can cancel out G term and we can divide both directions, both terms by time. Then we know that distance over time is velocity. In M1 V1, I will consider V1 as the velocity of this child, should be equal to M2 V2. Then linear momentum of this child is M1 V1. Linear momentum of this one is M2 V2. Linear momentums are equal and opposite. Therefore, total linear momentum is 0. Therefore, answer is B is correct. Then C. They should move so that momentum produced by one child about O is always equal and opposite to the momentum produced by other child about O. It's also correct. All A, B, C are true. Then answer is 5 for the question number 41. Then question number 42. Two blocks of mass 2m and m are placed in contact on a smooth surface as shown in the figure A. If the external horizontal force F is applied on the block of mass 2m, which of the following figure shows the force acting on two blocks correctly? There are two masses, 2m and m. When given a force to this mass, there is a reaction from this point, and there is an equal and opposite reaction for m mass according to Newton's third law. Weight of the 2m mass is 2mg and weight of m mass is mg. Surface is smooth, therefore there is no frictional force, but there is a reaction for these two objects. I will consider reaction of 2m mass is R dash, reaction of m mass is R double dash. We know that when considering vertical equilibrium of this 2m weight, R dash should be equal to 2mg, and when considering vertical equilibrium of this object, R double dash should be equal to mg. When comparing these two values, we can consider that R double dash is half of R dash. They have marked it as R. Then if this value is R, this value should be R over 2. And we have to get the reaction. When getting reaction, we can use F equals MA to the system in horizontal direction to the system. Then F is the resultant force. We have to substitute total mass 3m into acceleration. We can subject acceleration F divided by 3m. Now we can use separately F equals MA to this object and this object. I will consider 2m mass. Then resultant force is F minus 2m equals to mass 2m into acceleration F over 3m. We can get it easily by considering m mass. I will consider m mass. There is only one force for m mass. Then force is the reaction. I will consider it as R naught. Then force on m mass, horizontal force is R naught, equals m into, we can substitute acceleration F over 3m. Now we can simplify it. R naught is F over 3. Then answer is 3 for the question number 42. Then 43, a small sphere is released from rest from point A in a firmly fixed frictionless stack, which is a quarter of a circular path of center O and radius R as shown in the figure. The sphere leaves the track horizontally at point B and it falls under the gravity until it hits the ground. At a certain point C not shown, if the time taken and the distance travelled by the sphere from A to B and B to C are TAB and TBC, and TAB, TBC respectively, which of the following is true? There is a path like this: A, B, then object O. So the object is moving in this direction. They have given that the time taken to travel by the sphere from A to B, TAB, B to C. B to C means it should move like a path like this. C is this point. A, B, C. This height is R. This height also R. Radius of arc. Then we have to compare time and displacement. Time and distance. We know that when considering part AB and BC, at point A there is no vertical velocity, and at B there is no vertical velocity. Therefore, both situations, it should take a constant time, and this horizontal displacement also should be same, because of we can use st equals ut in horizontal direction. I will use from A to B. You know that velocity at A is 0. Velocity at B, horizontal velocity, I will consider it as V. We can use conservation of energy between A and B. At point A, there is a potential energy relative to this point, this straight line. I have considered potential energy 0 level is this level. Then potential energy at A, mgh, HLU is R, should be equals to half mv square. We can get an equation, V value is 2gr. It is from A to B. Final velocity. We can consider AB path. Time taken to move in AB path. TAB should be equals to TBC, because of there is no vertical velocity for both situations. But there is a horizontal velocity at point B. Therefore, this distance, now we have to consider distance means BC path. Length of BC path should be greater than AB path. SBC should be greater than SAB. There is a problem with given answers. This should be the answer, but there are two equal answers in question. Answer 3 and 5 are same. The answer should be correct, like this. In 44, an ant of mass 2 into 10 to the power 6 kilograms, it means 2 milligrams, which is stationary at the edge of a horizontal smooth strip, is removed in 0.2 seconds by blowing with mouth. If the direction of blowing is horizontal as shown by the arrow in the figure, if the ant is thrown out in the direction of blowing with horizontal velocity 0.5 meters per second, average force exerted by ant by blowing is, we can use force is rate of change of linear momentum. Force mv minus mu divided by time. But initial velocity is 0, therefore mu term is 0. F equals mv divided by time. Mass of ant 2 into 10 to the power minus 6. Velocity 0.5 divided by time 0.2. We can cancel out 2 and 0.2, 0.1, 5 into 10 to the power 6 Newton, 10 to the power minus 6 Newton. Then answer is 5 for the question number 44. Then question number 45. A block of mass 2 kg is pushed along a horizontal surface. The variation of displacement of the block with time t is shown in the figure. The values of the resultant force is acting on the block along the direction of motion during each of time intervals 0 to 2, 2 to 4 and 4 to 5 do not change. Which of the following correctly represent the magnitude of force in each of time intervals? They have given that we can consider the corresponding graph 0 to 2. We have to consider acceleration. 0 to 2 path is a linear path. It is like this. Therefore, displacement time graph is a linear graph. Therefore, it should has a constant velocity. When time 0 to 2, v constant has a constant velocity. Therefore, acceleration 0, then external unbalanced force also 0. We can consider time interval 2 to 4. At time 2, we can get velocity at 2 by the gradient of first part of the graph, difference of y1 divided by difference of x2. It means 0.5. You can get graph is like this. You have to consider gradient of this part to get the velocity for this point. And we can get velocity at 4 by considering gradient of this graph, this part. Difference of y 2 divided by difference of x 1. It means velocity at time is 2 meters per second. Then we can consider 2 to 4 situation. There are 2 seconds. Acceleration is change of velocity divided by time. Change of velocity 1.5 divided by time 2 to 4 2 seconds. Then we can use F equals ma to get the force. Mass is 2, acceleration 1.5 divided by 2. Then force is 1.5 Newton for the second situation. For third situation, again it is a linear graph. We have considered force for this part is 1.5. Then we can consider last part. It is a linear graph, therefore there is a constant velocity. Then acceleration 0, external unbalanced force also 0. Then external unbalanced force should be 0, 1.5 and 0. Answer is 2 for the question number 45. Then 46. Consider a massless balloon attached to one end of a light string. The balloon, the other end is attached to the bottom of water in a tank, which is fixed such as shown in the figure. The balloon is completely submerged in water. The velocity time graph shown shows the motion of truck, the position of balloon and string inside the water tank during the time interval T1, T2 and T3 are best represented by. Then considering balloon, it is in upward direction like this for the first situation. It means density of balloon should be less than the density of outer medium. Density of balloon should be less than the density of outer medium. Therefore, when accelerating system, for the first part of the graph there is an acceleration. We know that graph is like this, therefore it is a constant plus acceleration. When accelerating, this balloon should move to this direction, because of we know that if the density of considered object is less than outer medium, it should move to the accelerated direction. But if the density of this object is less than, outer medium, it should move opposite to the accelerated direction. Then in first part, balloon should move in this direction, and in the second part, there is a constant velocity. I will draw it First part like this. Second part, it is a constant velocity. If the system is at rest or if it is moving in a constant velocity, balloon should not move, then it is vertically. And for the last part, the graph is like this. It means gradient is a minus value. Therefore, there is a deceleration. We can consider it an acceleration in opposite direction. Therefore, balloon should move in this direction. Then we have to get the answer is 4 for the question number 46. Then question number 47. There is a diagram like this. There are two blocks A and B connected with this string, and there is a horizontal force F on the system. Pulley is connected to the ball. It is not moving. Two blocks A and B of mass 0.5 kg and 1 kg respectively are connected by a massless inextensible string which goes over a massless smooth pulley as shown in the figure. The coefficient of dynamic friction between all surfaces is 0.25. What is the force S needed to drag block B to left with a constant speed? With a constant speed, it means there is no an external unbalanced force. Therefore, frictional force, sum of friction, frictional force at this surface and this surface. Sum of frictional forces S1 plus S2 should be equal to given F force. We can get F1 force by using mu r. Mu is 0.25. F1 equals 0.25 mu value into r. When considering this friction, the action is only by block A. It is 0.5 kilograms. We have to convert it to Newton. Then I will multiply by 10. 5 into 25, 125. Into 10, 1250. We have to separate 3 decimal places. 1.25 Newton. By using same method, we can find F2 frictional force. In considering F2 frictional force, we have to consider total reaction. It means sum of weights of A and B. It is 1.5, frictional coefficient 0.25. We are using F equals mu r. This is the mu value, and we have to multiply by r. R is 1.5 kilograms. 1.5 into 10 Newton. 15 into 5, 75. 7 remaining. 15 into 2, 30. 30 plus 7, 37. 0. We have to separate 3 decimal places. 3.75 Newton. Then F should be equals to sum of these frictional forces according to this relationship. If there is no an acceleration, it means they have given that system is moving with a uniform velocity. Therefore, there is no an external unbalanced force on the system. Then we can add 5 plus 5, 0, 1 remaining, 2 plus 7, 9 plus 1, 10, 0, 1 remaining, 1 plus 1, 2 plus 3, 5. It is 5 Newton. Then answer is 3 for the question number 47. Then 48. A projectile suddenly explodes into two fragments with equal masses at the highest point of the trajectory. If one fragment falls vertically downward with an initial velocity as shown in the which of the following diagrams best represent the path of the other fragment? Neglect air resistance. The broken line represent the path of projectile. If there was no explosion. We know that there is no an external unbalanced force on the system. Therefore, if this original object is moving in this path, when it is exploded, should equal two parts. Center of gravity should be same as this point when considering system for the system. Then, if first part is moving to this point, its mass is 2m. This is the half of object, and then second mass should be moved to point like this. Finally, center of gravity of the system is midpoint of the line joining these two parts. If this one is x, this distance also should be equal to x. But when considering this part, there is a vertical downward velocity. Therefore, this part should move a path like this. It should have a vertical upward velocity, upward initial velocity. Then we can get fourth one is the correct answer for question number 48. Question number 49. An object of mass m stationary at time t equals 0 is subjected to a force F directed along a straight line that varies with time t as shown in the graph. Select the correct statement from the following. After the motion has started, the velocity of object becomes 0 at 40 seconds only, 70 seconds only, at 40 seconds and 100 seconds, at 70 and 120, during the time interval from t equals 60 to 80. They have given the force time graph. We know that force into time is the change of momentum. Force into time is the change of momentum. Therefore, we can consider change of momentum for first 20 seconds is the area of this part. It is equal and opposite to the change of momentum of this part. Therefore, it should be at rest at time 40. And change of momentum for this part, no, we can't get it. There is only one situation in the graph. Increasement of potential for this part is equal to increasement of momentum for this part, MV product, should be equal to decreasement of momentum for this part. Then it should rest only at t equals 40 seconds. Then answer is 1 for the question number 49. Then 50. Block A of mass 2 kg and block B of mass 6 kg are placed in a frictionless horizontal surface. Two identical springs of negligible masses are fixed to the block as shown in the figure. Block A is projected with speed 2 meters per second towards block B, which is at rest. What is the maximum energy that the two springs could attain? Now, we have to consider the conservation of energy. There is a kinetic energy for object A. It is half mv squared. Half into mass 2 kilograms, velocity 2, then 2 squared 4. This is the kinetic energy for object A. When considering maximum stored energy for the spring, for two springs, it should be equals to this one, because of this kinetic energy should be converted to potential energy of the spring. Then we can simplify it. Answer is 4 joules. This one is the correct answer for question number 50.